Hello, welcome to Telugu Oracle. In this video, let's discuss about relational database concepts as part of DBMS series. A relational database is a way of structuring information in tables, rows, columns, and relations between each table. In this, we will discuss about logical and physical data models with examples of create and select using SQL. The theoretical aspects of a relational data model or the logical data model, or sometimes it's called conceptual data model, represents business rules and the data structure of the database you are intending to create. It is DBMS independent, which means you can have same logical data model and you can implement it in Oracle as well as say MySQL or IBM System R. It consists of entities, as you can see in this picture. It consists of entities, attributes, and within entities, you have the attributes and relationship between each entity. For example, student enrolls into a class and department employs instructors and instructors teaches courses. So possible relationships between the entities, if you can think of, can be one-to-one. A student can only have ID card, so you have another ID card entity, so it'll be one-to-one with the student entity. And one-to-many, that means one department can offer many courses. For example, a computer science department, it can offer many courses like DBMS, operating systems, AI, etc. And then many to one. So if you flip it, say many instructors work in a specific department. So you have lots of instructors working in computer science department or mechanical department. And another one is many to many, which means you have many students enrolling in many courses. So this is many to many relationship. And then you have another one, and this is called recursive, and it's also called rabbitier. So this is like the relationship within the entity. For example, in the instructor entity, you have HOD, and that person is managing another instructor. So that's a recursive relationship. Physical aspects of a RDBMS or physical data model represent implementation details of the data model. So this will consist of tables, columns, indexes, constraints, etc. So these are called database objects, and these are created in the schema, in the database schema. Schema is something that holds all these database objects. So this physical data model is DBMS specific. So in Oracle, you will create these structures in specific way, and say in MySQL, you will create it in a specific way. For example, character data type in Oracle is varchar2, and in MySQL it will be varchar. And there are a lot of such differences. So this is why it is called database specific. And as you can see here, this is you have student table if you look at that. And then these are all the columns: student ID, name, date of birth, gender, address, phone, email. And then you can have you can define a unique key which cannot be null as well as a primary key. So that means student ID, it cannot be null, it can't repeat. So you can have only one student ID entered once in this table. And then gender. So you can have only specific list of genders. So you can create a constraint on that column. What that means is, suppose you try to insert data into the table, and if you provide a value which is not in that list of values, it will throw out an error. And then you have foreign key, which will basically student ID, so which will serve as a reference key, and which refers to the primary key student ID in the students table. And then you have something called index. These indexes are used to improve the performance when we query or update or delete using search. Uh, when you have indexes, it speeds up the process. It depends on the volume of data and a lot other parameters, but in the main purpose of indexes are to speed up the performance of your SQL statements or PL SQL code. So this is an example of physical data model scripts which you use to create tables and relationships between them in the database. It can be any database, but here I've used scripts for to create the tables and related data objects in Oracle database. So if you look at left hand corner, so you see there attributes tuple relation. So relation is basically what you call in the conceptual data model. In the physical data model, it's called table. And in the conceptual data model, and table will have table or relation. It will have attributes or columns. And then that defines the structure of the table. Then you have rows, which are tuples in conceptual data model, they're called. So suppose you create 100 students data here. So that means you are creating 100 rows of data. You are inserting 100 rows of data into this table. Now let's look at these two tables. So one is students and another one is enrollments. As we know, each student can enroll into multiple classes. So you can see here, student ID is a unique. Primary keys are both unique and they can't be null. And then you have email address. We have email, we have defined as unique. That means you can have only no two students can have no two students can have the same email address. But that can be null. So someone who has not provided the email address, so that null is allowed there. Then you have these enrollments, which you can see here, or different enrollment ID and student ID is also there. And then you define a foreign key. So foreign the student ID in enrollments refers to student ID in students table. What that means is that when you insert data into the enrollments table, it will reference the values in the students table student ID column. And if it is out of that range and not in those values, then it will throw out an error. And then you have for grades, you have this list of grades, which are allowed list of grades. And if you give some numerical grade there, when you are inserting data, it will throw an error. Then you have this index, which is created on enrollments table, the course code column, which basically shows that if I want to query a course in the enrollments table, so this index will be used. and it will be performance efficient. Look at this very quick example of a select query. This is ANSI syntax. Hopefully it should work for other databases as well, but this is I've tested this on the Oracle database. So what it shows here are different uh, data model concepts, how they are being used in this select statement. So you are selecting student name, course code, grade. So these are attributes of what? Of the entity, which is the students. And then, but you don't have course code and grade in the students. So what you have to do, you need to join it with a different entity, which is enrollments. And then you need to link these two entities with a relationship, which is the student ID in students equal to student ID in enrollments. But then I don't want all the students. I want the students who achieved grade A. So I introduce attribute filter. So I use grade filter and then add a value there equal to A. And then once I get the results, I want to order the results by student name attribute in the alphabetical order. So I use the attribute again in the order by clause. So as you can see here in a select statement, the different concepts of the data model are being used. Please comment any questions you have on the topic and I will respond.